Darn.
Alright, so today's lesson, guys, is called complex numbers. Right? And a complex number is just a real number and an imaginary number mixed together. We're going to start kind of with the basics, and then we'll get a little harder, but not too much. It's pretty straightforward. Start off with the square root of 16 is 4, right? Because we know that 4 squared is the same as 16. We use the positive principal value when it comes to radicals. Okay. If I asked you then for the square root of negative 16, we talked about this before, you can't get negative 16 with the exact same two numbers. 4 and 4 is 16, negative 4 and negative 4 is 16. So it doesn't work. So we call this, and we say that it's not a real number. In other words, it's an imaginary number. Right? And what they do with it is they still give it a value. Okay? They break it up into two things. They say, okay, I'm going to rewrite this then as negative 1 and 16. And the square root of negative 1 we're going to call I, and the square root of 16 is 4. So together we get an answer as 4I. And the I is written as an italics I. Okay, do not write your I, okay, as this. It's not a straight line with a tiny dot on the top. That's not correct. Okay, it's an italics I. Alright, so now, one thing you see that shows up a lot is when you take an I and you multiply together. So let me explain what I'm talking about. If I told you the square root of 3 times the square root of 3, you're going to tell me the answer is what? 3. So the square root of a negative 1, what value is that, guys? An I. Okay? If the square root of negative 3 times the square root of negative 3 is 3, the square root of negative 1 times the square root of negative 1, the radicals would drop and give you negative 1. Or you could say the square root of negative 1 is I, the square root of negative 1 is I. What's I times I, guys? I squared. So the value of an I squared is negative 1. That is very important. You might highlight it. If you see I squared, you write negative 1. It's the same thing. It's not simplified if you don't. Now let's write a little sentence here. And the directions are going to say, simplify. And if you're going to simplify it, there's one trick you have to do. If you don't do the trick, you're going to miss the answer. Okay? This is probably the weirdest part of today. It'll cause you to miss the answer for this one little issue. If there's a negative under the radical, you must pull the I out. Before you do anything else. You'll get the wrong answer. If you don't take out the negatives out from under the radical before you do anything, you'll miss it. Okay? Alright, so we already decided that the square root of a negative 16 is what value? 4I. Okay, so let's do one a little bit harder. What if I gave you the square root of a negative 24? Okay, square root of negative 24. That's the same as that's the same as a negative 1 times 4 and a 6, correct? When I take out the negative 1, what do I get? If I kick out the negative 1, I'm going to get an I. If I kick out the 4, I'm going to get a 2. Put the 2 in front of the I. And what does that leave inside? A 6. Before I go any further, though, I'd like to show you something really quick. So if you see, and I'm going to do something really simple. So if you see 5i, okay, go back to let me show you something we talked about before. If I told you 5 to the negative 2 power, doesn't that just mean when I subtracted exponents, I had extra left where? In the denominator. So this is 1 over 4 squared, correct? Well, if you see an I next to a number, it doesn't mean a whole lot. All it meant is that inside the radical, there was a what? Guys, here. There was a negative. So in other words, if I have an I here, it meant if I took this radical and I put both of these back in, if I put the 5 back in, it would be 25. If I put the negative back in, it meant it was, I'm sorry, if I put the I back in, it meant it was negative. That's all. So when you see a number and an I, it meant somewhere there was a radical with what underneath? A negative. Okay? That's all it is. Let's go to number 2. The square root of a negative 48 x to the 6th power. Break it up as a negative 1. 48 would be what? Some kids earlier were saying 4 and 12. The problem, let me show you the secret about 4 and 12. The problem with 4 and 12 is 12 can be broken down again to another 4 and a 3, right? So it's not 4 and 12, it's 16 and 3. And then bring down your x to the 6th. So if you're going to kick out everything, I'm going to kick out the 16 to give me a 4. Kick out the negative 1 to give me an I. What else can I take the square root of? Right, x to the 6 makes x squared. And what stays inside? The 3. I forgot, I'm sorry, divide by 2, not, thank you. 6 divided by the square root is 3. Thank you. So 4ix cubed square root of 3. Number 3. 7i squared. What did we talk about I squared meant? Right, it meant there's 2 negatives under the radical, right? So when you drop the radical, you get negative 1. So here, this value is negative 1. So what's 7 times negative 1? Square root of 4, negative 4, I'm sorry, times square root of negative 9. This is where that paragraph we wrote just a second ago makes a difference. The paragraph said you have to take care of your negatives under radical before you do anything else. This is the reason. If I take negative 4, right here, and I multiply by negative 9, we can get positive 36 and tell you the answer to the square root of the 36 is 6. But that's not true with this problem. Okay? Because you have to take the negative, you have to simplify the negatives first. This is actually what? What's the square root of 4? 2 and square root of a negative 1? I. So this is 2i times, what's this give me? 3i. 2i and 3i make 6i what? Squared. So this answer is not 6. It's actually what? Yep, this is negative 1. So the answer is actually negative 6. Number 5. The square root of a negative 2 is the square root of a negative 20. Again, you have to break the negative, or take the square root of the negatives first. Then you can simplify. Can I take the square root of a 2? No. This is like negative 1 times 2, so you're going to make this I root 2. I'm going to keep this out. This is like negative 1 times 4 times 5. I can take the square root of a 4. So what does this give me actually? 2i root 5. Y'all see how come? Okay, so now outsides, insides. I and 2i make 2i squared, and root 2 and root 5 make root 10. Okay, where do you see I got one more step to finish? What does this turn into? So 2 times negative 1 is negative 2 root 10. Negative 3i times 8i. This is going to give me negative 24i squared, but I squared is the value of negative 1. So the answer is actually 24. Everybody comfortable with it so far? Negative 3 times 8 is negative 24. I times I squared. The value of I squared is negative 1. So negative 24 times the negative 1 is actually positive 24. Okay, when you get to this point, you want to do outsides, insides, but you can't do outsides, insides until you do what? What do you have to remember to do first? Get rid of the, what? Get rid of the negatives. So if I kick the negative out, take the square root of negative 1, I'm going to get 3i root x. If I take the square root of negative 1 again, I'm going to get negative 7i root y. I'll give you a second to keep going from there. These together give me negative 21i squared root xy. The I squared is negative 1. So actually I have 21 root xy. So the biggest thing to remember, okay, is if you have negatives, before you can simplify, you have to pull the i's out. Take the square root of negatives first. All right. So now then, switch gears a little bit. If I ask you for the square root of 16, you say 4. If I ask you for the square root of negative 16, what are we going to say now? 4i, correct? What if I ask you, if I say x squared is 16? What kind of picture would that make? If you have an x squared, what kind of picture would that make? So how many, a parabola, good. So how many, it's quadratic. How many answers does a quadratic have? How many? 2. Typically 2, okay? 2. Now, my question next is, then what are the 2 answers here? 4 and negative 4, right? 4 squared is 16 and negative 4 squared is 16. If you have an x squared in a problem, guys, you're going to have 2 answers, okay? It's quadratic. Now let me, just for a second, on a little side note. If I gave you x squared plus 5x plus 6, you have an x squared, it's quadratic, right? So your two answers come from, because you have an x squared and an x term, they come from factoring this. -2, -3, right? But in this problem, I don't have an x term. I have x squared and a number. So it's even easier. You don't have to factor, you don't do any spare work, nothing. The answer is just positive and -4. But you still have two answers. Okay, here's your parabola, +4, -4. Does that make sense? Okay. So on that note, let's solve these. And it's kind of, you remember we studied polynomials not too long ago? If it's a cubic, how many roots can it potentially have? 3. If it has a fourth power, how many potential answers will it have? 4. Well, this is quadratic. It's power of 2. How many potential answers is it going to have? 2. Okay? A positive answer and a negative answer, because there's no x's, there's no factoring, right? Only an x squared term. So move your 25 over. And I want x squared to be a -25, which is not possible. Right? 5 squared is 25, and -5 squared is 25. Do you see what I mean? But when you take the square root of this and think about it for a second, so what does my answer have to be? It's x squared, so it's a positive version and a negative version of what? What is this 5 what? 5i. Because just regular 5 wouldn't work. Number 2. B squared plus 10 equals 0. What are you going to do with your 10? Yeah, move it to the other side. So now you've got b squared equals -10. Take the square root of both sides. So b, okay, it was a quadratic, so plus and minus. I can't take the square root of 10, so it's just I root what? 10. I can't break it down anymore. Number 3. Four x squared plus 80 equals 0. Move your 80 over. Divide by your 4. Your square root. Positive and negative, right? You need two answers. And there's nothing to factor, right? So it's got to be a positive and negative form. This is like a -1, a 4, and a 5. So it's 2i root 5. Everybody feeling pretty okay about it? It's not bad, right? Okay, we're going to add something new now. How about complex numbers? This part's easy as well. Complex numbers should be written in this form. Guys, a complex number is a real number mixed with an imaginary number, correct? So far, when we've done complex numbers and we mix them, they're all multiplied, so we just kind of slammed them all together, didn't we? Okay? But if it isn't all multiplied, and you have a real and you're adding an imaginary, then you do it in this form, a plus bi. Or in other words, kind of a real way is 3 plus 2i. You put the real number first, and you add the imaginary after. Complex numbers. Okay, so let's try some. Okay, we're adding, right? So we're going to add all the reals, and then we're going to add all the negative ones. All the imaginary ones, right? Okay, so what are my reals? What can I put together? A 7 and a -4, which gives me 3. Then we're going to take the 5 and the -6 out, which gives me -I. Real, then the imaginary. Alright, our next one, number 2. 4 plus 6i minus 2 minus 7i. What mistake the kids make right here? You know, just tell me what it is so that when you grade test for me, you'll know what mess you're going to make. What?
I'm not thinking of that.
Jake, what mistake do we make? You don't know? Raise your hand. The negative, right? Kids will do 4 minus 2 and they'll be fine, but what they forget is when they move over to the second part, they forget that it was a subtraction. Okay? So, if you want to make sure you don't mess up, distribute right away, then you don't have to worry anymore. So then, you're going to take your real part first. 4 and -2 makes 2, and 6i and 7i make 13. The square root of the -50 plus the square root of a -18. Clean them up first, please. Give it a shot. Did you get 10i root 2? Good. It's not. No, it's not. I was just kidding. Okay, let's try. You're going to have a -1, a 25, and a 2. You're going to pull out a 5i root 2. -1, 9, and 2. So we're going to take out a 3i root 2. So together we get an 8i root 2. I was just kidding. Number 4. 5 root -3 minus 4 root -12. I can't break up the 3, so all I'm going to do is take the square root of the negative. So 5i root 3. This is -1, 4, and 3. So we kick these out. You would, okay, watch this part. Ready? This is probably the hardest one. So this becomes 2i that I'm taking the square root of. But what is already out there? A 4. So a 4 times a 2i make how much? -8i. 5i minus 8i is -3i root 3. FOIL, right? Okay, so your first line will be 28 plus 21i minus 8i minus 6i squared. We're gonna, first of all, you never leave a what? What can we not leave here?
I squared.
The I squared. This value right here is negative 6 times negative 1. So what does this turn into actually? Plus 6. Now then we combine reals and then imaginaries. So get rid of your I squared and combine reals and then imaginaries. So 28 and 6 are going to give us 34. And then 21 and negative 8 give us your 13i. Is there a trick to square something? Binomial squared, right? Firsts, multiply them together and double it, and lasts. So use your trick here if you want, or you can rewrite it and FOIL it. 3 squared would be 9. Multiply them together and I'm going to get 6i. How many 6i's do I really need? 2, so I'll have 12 i's. Then I'm going to square 2i. Do you think about it? What is 2i squared? It's right. It's 4i squared. We take care of the squared first, so this is actually 4 times negative 1, so it's negative 4. So give your I squared. Now combine your reals. 9 and negative 4 make 5, and then add in your imaginary. It's a very complex number. Okay. Alright, so everything we've done so far is pretty easy. The last thing we're going to do is a little bit abstract. So, kind of if you've tuned out, tune back in and focus pretty good right now. Alright, this is, I think after I do about 3 of them, you'll be fine. Right? It may take 4, but 3 should be good enough. We're going to start with something really basic. I'm going to ask you to tell me the value of I to the 6th power. First of all, how many i's is that? 6 i's, okay. 1, 2, 3, write them all out for me. 4, 5, 6. We're going to need to learn a shortcut because if I asked you what I to the 106th power is, I wouldn't want to write out 106 i's to find the answer. Okay, so I'm going to do it with 6 and kind of show you the pattern. What do we know that an I times an I gives me a value of what? Negative 1. Okay, do you agree? So then what you can do then is we're going to break this up into groups of 2. Why am I breaking into groups of 2? Because I know I times I is what value? So every group of 2 I get, okay, I'm actually getting a value of negative 1. Negative 1 times negative 1 times negative 1. Right? If I could break it up into groups of 2. Because every time I have a group of 2, my value is negative 1. Well, how many groups of negative 2 do I have? 3. Well, if you have an odd amount of groups, your answer is going to be positive or negative. If you have an even amount of groups, what's your answer going to be? Okay? You getting the pattern, kind of? There's one more pattern, though. I did 6. There's a perfect amount of groups. What happens when there isn't a perfect amount of groups? There's going to be an I left over. Okay? Do you see what I'm saying? So you need to figure out how many groups you have. If your groups are even, you have a positive. If your groups are odd, you have a negative. If your groups are even and you have an I left over, you have a positive I. If your groups are odd and you have an I left over, it's a negative I. So I'll show you. Okay? But some of you may have seen the pattern that quickly. So what you can say to yourself is, we know the answer is negative 1. So if you look at this I squared, right? That's what it has a value of negative 1. How many I squareds are there in I to the 6th power? How many groups of 2s are there? 3. Okay, so that's the part you need to write down. I've got I squared and I know there's 3 of them. What's the value of an I squared? Negative 1. So if I have 3 groups of negatives, is my answer positive or negative? Negative. Okay, did I have any i's left over? 3 groups of 2 makes how many i's? 6. No i's left over, so my answer was just -1. What about if I asked you for I to the 13th power, and we don't want to actually write out 13 i's? Okay, we're going to do the shortcut. Right? We know the value of I squared. We know it's -1. How many groups can I combine together? If it's an even amount of groups, my answer is positive. If it's an odd amount of groups, my answer is negative. So how many groups can I fit in perfectly? 6 groups, which gives me how many i's though? Only 12 i's. How many i's are there in my problem? So what am I going to attach to this? An I. So I have an even amount of groups. So is my I positive or negative? You have an even amount of groups right here. Okay, because this is the same thing as -1 to the 6th power. So 1. 1 times I is I. Let's try another one. We're going to do 2 more. I'm hoping by the 4th one you'll get it. Here's I to the 67. You try it on your own for a second, and then we'll check it. How many groups of I squared can fit in? If it's an even amount of groups, you know that it's a positive. If it's an odd amount of groups, you'll know it's negative. And then you have to decide if there are any i's left over. How many fit in to 67? 33 groups gives you 66 i's, right? Okay. Do I have any i's left over? Right, because I needed how many i's? 67. So I had an odd amount of -1's. So is this part positive or negative? Think about it. -1 to the 33rd power, is that going to be positive or -1? -1. -1 times I is -I. You're only going to have 4 answers. I, -I, 1, or -1. That's the only possible options. Try one more by yourself. How many groups of I squared can you pull in? And then decide if there's any left over. If there's no left over, your answer is just going to be positive or -1. Because they fit in perfectly, like the first one we did. Cancel all of them. Then you just have to decide, did you have an odd amount of groups or an even amount of groups? So how many groups of I squared are there? 35 groups. So wait, are there any left over? No. That's 70 i's. So -1 to an odd power is what value? -1. All right, you need to start your